So obviously the where statement can be complex. Here is an example of the and or logical operators as well as the negation. So I think it's important to remember that and returns true only if both statements are true, right? So if the vendor state is New Jersey and vendor city is Springfield, only if the case in each row both strings are like that, the where statement will return true, or requires only one of the statements to be true, and then this is the logical negation, something that we did a moment ago in the previous example with the not null. It is important to also remember that combining ands and or is notoriously dangerous and difficult to debug, because the true tables of mixed and ors operators are very unpredictable. So if you think that you can figure it out without designing the actual true table for a specific statement, then you probably are in for some trouble. So in and ors, just use sparingly, or do not try to build too complex statements. What we are looking at is a possibility for two mathematical comparisons, both negated, but as you can see, the negation is in front of the parentheses here, and then the negation is inside parentheses here, right? So this negation basically can be accomplished by simply switching that operator to the other side, right? Instead of smaller than, you need to have a greater. Smaller equal should be replaced by greater, right? So this negation can be accomplished by just changing the direction here on this sign. So I guess I would say that I don't have a good way to simplify things if we are talking about those logical operators. They might be kind of unpredictable, so you can compare them over here, but I guess it's just better to just specify the conditions right away, the way you want them, and then maybe use a single and single or. Also, on top of the complex truth tables, if we are mixing things up, also remember that there is an order of operations. So if there is a not, it takes the precedence, and then or. I'm not sure if this is in the introductory SQL class, if this is useful information, but we will try to avoid. I think it's even for a complex statement, I think it's a good style to use a very clean compound statements if they have to be compound, and that will be our objective in this. So the where statement has a very useful addition in which we could enumerate the filter items. So, for example, the where statement, right, might identify the column. Well, has to identify the column that we will be filtering, and then we have an in statement that enables us to enumerate. So, for example, retrieve only values if in the terms ID column, the values are 1 or 3 or 4. Or if we are enumerating characters, strings, we would enclose those in quotes. So this is an interesting interesting addition, very, very useful. Now, also, now in this context, you see that there is a possibility for us to build a subquery. So this is a new syntax for us, where we can have select something something, right, from something something, where this particular column is filtered and the criterion is another SQL statement, possibly coming, maybe from a different table. So you can imagine a scenario in which we are talking about some sort of a transactional system, and it's registering data in one table, and then the invoices give you the dates, and you would be interested in seeing whether in some other table, what happens, let's say, in some other table, given that in the vendor ID or invoices table we've got this kind of a date. So so the syntax is now basically integrating two select statements. So where vendor ID is resulted in the output from the vendor ID, possibly from another table or maybe from this one. So here is the description of this nested query. So let me maybe start here with the general syntax. So let's say we have our invoices, and you see select star, right? This is the whole data set. Now I would like to test a query that looks like this. So select, let's say, vendor ID and invoice total from invoices, and that's the name of the table, right? Where vendor ID is given, it's enumerated, right? Vendor ID in, meaning that I will get a bunch of ID numbers, and that bunch is given from a criterion coming from another query. So and that query is, let's say, select vendors that, let's say, had an invoice total smaller than $40.20. Right? So there have been transactions involving some vendors that resulted in an invoice that were, let's say, smaller than $40.20. So that query is, I executed for testing that query in here. So you see all these vendors, all these numbers, vendor 123 and 95, all these vendors registered transactions that are resulting in invoices totaling less than $40.20. So let's take a look at our query that is showing the whole data set, and let's take a look at our transactional database that is filtered. So again, the logic here is that I wanted to show all transactions involving all invoices for vendors where for vendors that have been filtered. What was the filtering criterion? Well, the filtering criterion was transactions below $40.20. These vendors may have other transactions recorded into our invoices transactional table, but in here, this select statement is filtering by the vendor ID. So the same vendor might have, higher transactions, lower transactions. That is something that we were interested in. So maybe the business logic was, okay, well, let's take a look at vendors and let's see, how these vendors that have smaller invoices are doing, with the bigger invoices or something like that. So this is a powerful statement that is enabling us to create in a modular way a complex queries, because you can see that this statement, this query here, can be plugged into a separate query window and just executed separately for testing purposes. So this is a beautiful tool for a database programmer to create very complex but modular, easy to debug statements. I like very much the statements that give us intervals. So this is again a very expressive tool. So the general syntax is where, right, and then we have to identify the attribute, and then perhaps logical negation, and then between this and this. So there will be two conditions. Those conditions could be dates, for example, in quotes, or could be numeric values, and then logical negation, so everything except numbers ranging this geographical, describing this geographical area. Or here an interesting statement, right? So the attribute can be combined. So the value in this column minus the value of this column minus the value in this column, that is going to range between this and that. So then also we can have a value in the between statement that is coming from an attribute, credit total plus 500. So let's take a look at an example of those statements. For example, let's take a look at a few items in our invoice database. So we have invoice total, payment total, and for in a few cases we have a invoice invoice total payment different than the payment. So we have a credit total that is non-zero. So obviously, we have, if we want to find if somebody's got a credit total that is non-zero, we can simply search for a value in this column. But let's assume for a moment that we don't have the column credit total, and we would like to maybe find some of these records that have a non-zero or a value in a certain interval that is going to be a result of a subtraction of the invoice or payment from the invoice. So let's take a look how to build that kind of a query. Here is our simple query. So let's select ID, vector, vendor ID, invoice, and payment total, and then from invoices, right, from our table, where or maybe let me move this around. So where invoice total minus payment total is greater than 100. So obviously, if you look at this row, invoice total minus payment total is greater than 100. This minus this is greater, this minus. So we have identified a certain group of, I guess, unpaid invoices or invoices that haven't been paid fully. Obviously, having the credit total of column in our table kind of solves our problems, but one of the design issues could be, okay, well, do I have to keep all this data in my table, given the fact that a very simple query can dynamically generate the data that we are interested in? So something to think about when it comes to the table design, and I guess significant question here.